Hi, I'm Michael. I'm a tutor at the Alpine Prep Academy. I did the IB last year at Bexley Grammar School in London, and I managed to get 41 points out of 45. My higher levels were maths, physics, and economics, and in all three of those, I managed to get a grade 7. Today I want to talk about a topic in Maths AA that students get muddled up on sometimes. It's called implicit differentiation. And we use this when a function is expressed implicitly, as opposed to it being expressed explicitly. Let me explain what that means. Sometimes, or most of the time actually, functions look like this. We have x on one side, and we have y on the other. This is an explicitly expressed function. This is what we're used to, but sometimes functions don't look tidy like this. They look a bit weirder, something like this. You see, we have both x and y on the same side, and y isn't isolated. It looks untidy. This is called an implicit function. This is still a smooth curve, though. It's still continuous. We still want to find the gradient of this curve, and we still want to find the turning points of it too. So that's when we have to use implicit differentiation. This is the part where students start to get confused. Examiners want to see if you recognize that y is a function, and that when we differentiate y, we have to use the chain rule. So we have to recognize that y is not an independent variable. Y depends on x. As we see up here, y very typically depends on x, and that's the same as what's going on down here as well, which means it's a function. So when we differentiate a function, we know we have to use the chain rule, and that's what we have to remember to do when we're differentiating this implicit function. So let's go ahead and do that. Differentiating 2y, let's see what happens. So typically, we bring down the 2, and we take 1 away from it. And then we have to remember, and this is what examiners are looking out for, we have to remember that y is a function as well, which means we have to use the chain rule. So we have to multiply by dy by dx. And then moving on to the middle term, we differentiate the x part, we get 4y. And then we differentiate the y part, we have 4x. And again, we have y, so we have to use the chain rule. We have to multiply by dy by dx. And then moving on, x cubed is simple to differentiate, 3x squared. And the derivative of 7 is 0, it's a constant. So now look, we have an expression that has the dy dx term. And that's what we want to isolate so that we can find out what the gradient expression is for this thing. So let's just try and isolate dy by dx. And then we'll move the rest to the other side. And then we're going to factorize dy by dx out. And then we're going to divide both sides by 2x plus, oh sorry, there should be a y here. We're going to divide both sides by 2y plus 4x. And that gives us and that's that. So something to remember is when we're doing implicit differentiation, we have to pay attention to the fact that we have to use the chain rule because y is a function. Let's try apply this knowledge to a question. A curve C is defined by the equation x squared y plus cosine y equals 2. Okay, using implicit differentiation, show that dy by dx is equal to so-and-so. Okay, let's try that. Well, differentiating the first term, we have to use the product rule. So the differential of x squared is 2x, and then we have y, and then we leave x squared, and we have to use the chain rule. What's the derivative of y? Well, y is a function, therefore we have to put dy by dx. And then differentiating cosine y, we have to use another chain rule. So the derivative of cosine anything is typically minus sine of anything. In our case, it's sine y. And then we have to multiply by dy by dx. Again, we're doing implicit differentiation. And then the derivative of 2, again, is just 0. So nice. Now let's try and isolate the dy by dx term. I'm going to do a few steps in one go. I'm sure you guys can keep up. And then you subtract 2xy. And then let's divide by x squared minus sine y. And voila. That is the answer. Minus 2xy over x squared minus sine y. And that is exactly what we were looking for. So again, this question is made to test if you recognize that y is a function. We have to remember that y is a function, and that means every time you differentiate y, we have to use the chain rule. When expressions are given explicitly, that's exactly what you have to keep in mind.